Hello everyone, my name is Rahul and welcome to my channel DevOps Forge. So today we are going to learn loops and dynamic infrastructure, where the first technique is count, which we have used in our previous lecture. Then we will understand what is the problem with count, and after that we will understand how for each solves it. Then later we will understand the dynamic blocks. So without wasting any time, let's get started. In previous lecture, we understood some built-in functions, right? But you must be thinking that, Rahul, you defined the lookup function, the CIDR subnet function, the for expression in list and map for instance server names and instance tag, but you have never used it, right? Inside my main block, I have never used it. So I kept all of these functionalities untouched intentionally because I'm going to extend this particular example into my today's lecture. So first of all, what I will do, I will copy all of these files into my lecture 5, right? And then let's extend this particular example, okay? So first of all, for the instance type, I have used local.instance type, which is what? It is derived from the conditional expression. So we could have used in either way, either for lookup function or for conditional expression. So for the first example, I've used the conditional expression, and for today, we are going to use the lookup function. So instead of adding the instance type over here, I will add instance type lookup. So it will similarly do the same work and create my instance. Now let's move ahead and see what else is left. So CIDR subnet function is the one which we have talked a lot about in our previous lecture. So let's extend this as well. What to use the CIDR subnet function? First of all, we need to create the VPC, and we have defined our prefix over here, right? So with this IP address, I want to create a VPC, and inside this I want to create the subnets so that I can use the CIDR subnet function, right? So first thing, I will define the VPC and I will say AWS VPC, right? The name, I can keep it as main, okay? And I will add the CIDR block, and you know very well that we will extend it from our variables.tf, and we have var.subnet CIDR, right? Then for tags, let's say I am going to merge, okay? I'm going to merge the local dot instance tag, right? And then after that, what I can do is I want to add some more tags over here. So I will name my VPC, let's say main VPC, and I will name the environment, okay, and say it is for dev environment. Now we have our AWS VPC, right? So let's add a comment over here and say it is a VPC. Next thing is our VPC is defined. Now we want a subnet, right? Similarly, I'll just create a resource of AWS subnet, and the autocomplete will help me, and I will say that this is a public subnet. Why we need public subnet? Because we want to connect to our instance, right? So for that we need a public subnet. Okay, so what is the issue? Okay, let's define the attribute. It is saying define the attributes, right? So first of all, what I will do is I will reference this particular AWS VPC into my subnet and launch our subnet into this VPC. And we know how to reference this. And in our second lecture, we have understood how to use resource type address, right? If you haven't seen that, go and watch that video. Now I will do this. I will take the main and take the ID. Now my subnet is associated with my VPC, correct? Now for the CIDR block, what I'm going to do is I'm going to use this subnet 1, which have the CIDR subnet. And if you remember in our previous lecture, what we understood, the derived value for this was 10.0.1.0/24, right? So this value will be populated over here, okay? So I will say local.subnet1, and for tags, let's again use the merge function and say that local.instance tag I want to use. Along with it, I want to give the name of my subnet as public subnet. Clear? Now we have used the CIDR subnet function. We have created the VPC. The subnet is associated with that VPC. Now let's move ahead and see what we can do in this particular block where we are adding the configuration for our EC2 instance, right? So for count, you already know we have used it, and it says local dot total servers, right? And it is derived from here. So basically what it is doing is it is iterating through the list which we have defined for the server names, and it is creating two servers, isn't it? So there is a problem with count, and let's understand it very clearly, because in production or in the mainstream applications, we don't use count more often because there is some limitation to it. And let's understand what is the limitation. We have this list, right, defined in our TF file, and you know that inside this, these are the server names which I wanted, with which my EC2 instance should be created: API server and web server, right? So we were understanding the problem with count. So when we used count, basically it converted my instance into this format, which is the AWS instance dot web count 0 is API server and web count 1 is web server, right? In the previous lecture, in the console, you have saw that the 0 was the API server and 1 was the web server. So the problem with count is if you change API server, this list, to, let's say, web server only, right? So what will happen? Terraform will do destroy this API server, it will destroy this one, and then it will recreate the web server. So this basically is called index shifting problem, right? So what is index shifting? So when you use count, Terraform identifies resource by numeric index, which is 0, 1, in this way, right? So if you, let's say, define 3 server names, then it will identify the resources through this index, right? And if the order of your list changes, Terraform reassigns indexes, which can lead to unnecessary destroy plus recreate of resources. Now when you change the list, like I said, it will destroy this one API server and it will recreate the web server. So how Terraform sees this, it is like, let's say API server is for server for this 0 index and web server is for 1, right? Let's just remove this one, and let's say the first time you applied with the help of count, then these were the resources which have been created, and it can be considered old state, right? So when you change the list, what it will do is the new state is, it will say that, okay, now I only see one index which is 0, and I will only create web server, which will result to recreating this web server which was already created and destroying of API server, even though if I wanted the API server to be unchanged, right, or not to be destroyed, right? So this was the problem, and this problem is like basically solved by for each. And let's understand one more thing, that Terraform, if you use count, then Terraform identifies the resources using the index. It will see that, okay, if this particular index is there, it is a resource, right? And not like this, the name, okay, not like this. So here we just changed this one, we removed this one, and the name was same. Even though the name was same, the Terraform will do recreation of this particular instance, and then it will destroy the API server. So when indexes shift, Terraform thinks this is a completely different resource and it creates this, right? So the problems over here, like I said, in real world or real world application or mainstream applications, or even in production environment, this can cause downtime, the data loss, service disruption, and also it can have unexpected infrastructure changes. Okay, so what is the remedy for it? Instead of index based tracking, what we can do is we can use key based tracking, okay, which is provided by for each, right? So which is provided by for each. So in this example, you see, instead of indexing it, what for each does, it will say for each API server and for each web server, right? So through the example, let's quickly understand this. So inside my main block, let's remove this one. Inside my main block, what I will say is for each to set, right? And I will say var dot server names. So what it will do, it will do key based tracking instead of index based tracking. And then I will just add a comment over here. Okay, I will say that for each expands resources, right? And this particular lookup is evaluated through this for each. Okay, I will write lookup is evaluated by for each. Okay, and even though this lookup returns a single value, right? It returns a single value from here, right? Which is when we pass var.environment as dev, a single value will be passed and it will say that, okay, you want to spin up a dev instance, right? So then in that case, even though lookup returns a single value, that value is applied to each instance created by for each. Okay, rest I will keep the same, and for tags I will change it. What I will do is I will do a merge of local dot merge tags. You remember we defined it, and what we will do is I want to add a name, but what we'll do, we will use each dot value, right? In this way, whatever the value will be here. So for example, the first is API server and the second is web server. This will be passed over here and it will create two instances with different names, correct? So what Terraform will create, it will create in AWS instance dot web for each API server, and similarly for web server. So why for each is better? So even if you remove the API server, only API server is destroyed, web server remains unchanged, correct? Now moving ahead, let's understand dynamic blocks. Okay, so I have already kept this example ready. So let's understand the dynamic blocks. Now when you use dynamic blocks, it use the nested blocks repetition, right? And where it can be helpful in our example, it can be helpful in security groups. So let's make a visualization chart over here with which like we can see that how this works, right? The dynamic blocks. So let's say I will take an example of security groups. Okay, and let's say the allowed ports for the security groups is 22 for SSH, 80 for HTTP, and 443 for HTTPS. So what it will do is the dynamic block will loop through this and it will create the security group with the ingress value of, just a minute, with the ingress value of 22, the next time it's 80, the next time 443. Similarly, you see over here, first it will create this ingress, then second, then third. So this can be helped when we want to use the repetition or we want to loop through for a particular use case. Let's take the example of dynamic block. So for that, I will create a resource, okay, security group, and the name of my resource will be web_sg, and the security group name will be web-sg. Okay, now let's create the dynamic block and say ingress, right? So I will do one thing. I will create a for each block and I want to use some of the ports, right? In our example, you see we used 22, 80 and 443. So let's do one thing. First go to variables.tf, create a variable called allowed ports, okay, and the type would be list of number, right? Now in the next step, inside tf wars file, I will define this, okay. So the first is 22 and we want 80 and we want 443, correct? Now next thing is let's use the allowed ports over here, and what it will do is we want to define a content as well. So basically this content will loop through this particular value whichever will be present over here. So for example, var.allowed ports are 3, so it will loop through these 3 values and it will populate those values into our security group. Now inside the content, let's see what we can add. So from port we want ingress value, okay, and to port. So these are some of the configurations of security group, right? Now let's add a protocol, which is basically TCP I want to add, and let's say the CIDR block from where I want the traffic to flow, I just keep it to all. So basically 0.0.0 means the traffic will flow from all the internet. Okay, now the security group is done. Okay, so next thing is what we want to do is we want to reference this particular security group inside our resource instance. Okay, so let's do one thing. So first of all, for instance type, we are using local.instance type lookup, okay, and we are using for each, right? So when we are using for each, we want to comment this out, right? Count, because at that time it will throw error and the Terraform will say that you have defined count and for each, both of them, in which way you want me to create the EC2 instance. Okay, so let's reference the security group and it is referenced through the security group IDs. Okay, quickly I will add the security group web.sg.id. One more thing we are missing is we haven't defined the subnet inside which we want our EC2 instance to be present. Okay, so we have created this subnet over here, right? And we will reference it in this EC2 instance and associated. So let's say subnet ID, and I will do .public subnet.id. Cool. So we cannot directly attach the VPC to our EC2 instance. So what we can do is we will attach the subnet ID, okay, the public subnet, and which in return is associated with AWS VPC. Now let's do one more thing. So we will attach this security group to our VPC, okay, because if we do not attach it, then what will happen? This particular security group will be created inside a default VPC, and we have created our custom VPC. So in that case, first the subnet is associated, then security group is associated, and then my EC2 instance is associated with the subnet so that it can reside into this particular VPC, correct? Now quickly initialize the backend. Okay, it will take some time. The backend is initialized. Let's do a Terraform plan now. and it will show me, yeah. So these many resources are going to be created, and in our previous lecture we saw that there was .web0 as the API server and it was doing index based tracking. So now what it does key based tracking with the key as API server, and the next key is web server, right? And all of the information you can check over here, you can go through it. Now let's quickly do Terraform, apply. Let's wait for some time. I will say yes, and let's see if we have done things correctly or not. And it is creating the VPC, right? The creation is completed. Subnet, it is created. The security group is created, and now it is creating the EC2 instance and associating it with the subnet, the security group which we defined inside that particular VPC which we defined over here, right? Now let's wait and see if the resources are created. Okay, so 5 resources added, 0 changed, and 0 destroyed. Now quickly we will go into our console and check. Okay, I will refresh this and let's see if the instances are there or not. Yeah, it is there with the name API server and web server. Now let's match the ID 54F4 and 1230. Okay, so we can see 1230 and 54F4, right? And I will take example of one of the instance. I will check this. Okay, so this was the name of our VPC, if you remember, main VPC. I will open this one, right? And yeah, this is the name. And let's see what else is there. Okay, these are the tags which we created, isn't it? Now next thing is we want to check the security. So these were the security port range which we defined into our dynamic block. Yeah, and these were the allowed ports, right? The security group name was WebSG, if you remember. If you go over here and see inside security group, yeah, this is the name WebSG. Similarly, it is present over here, WebSG. Okay, and this security group, let's see where it points it out. Yeah, this is the one. Okay, and for subnets, let's do one thing. Go to VPC and let's see. Okay, so this was the prefix which we used, right? If you remember. And then for subnets, let's go over here and check. See, so 2 subnets have been created because we had 2 EC2 instances and each one is attached to one of the EC2 instance. Now let's click this one. Okay, so it says it has available IP4 addresses 251, right? But in our previous lecture, I have said that it has 256 addresses, IP addresses into a particular subnet, but it has only 251 over here. Why? Because 5 of the IP addresses are reserved by AWS itself. That is why we can see 251 IP addresses are there. And see, I told you 10.0.1.0/24 will be used into this particular subnet. This is the IP address which will be used, and particularly this is the one which has been used, right? So if you have some doubts, you can see the previous lecture, you can rewatch it, and the same way, like I said, this IPv4 address will be used. It has been used. We can see 251 IPv4 addresses available over here, and this is associated with my EC2 instance, right? You can see the tags are also there. So now we have understood each and every concept, right? So if I just go through this topic, and inside this we understood all of this function, CIDR subnet, right? And for expressions we understood loops and dynamic infrastructure. Now next we will understand the Terraform dependency graph, which will have implicit dependencies, explicit dependencies, graph visualization, and etc. So we'll meet in the next video. If you like this content, so subscribe to my channel and let's meet in the next video. Thank you.